The next topic is clock stretching. It is really interesting to know that it's not always the master that controls the SCL serial clock. In some cases, the slave device can slow down communication or data transfer. The reason the slave device will need to slow down could be the following reasons. 1. ISR needs to be serviced by the slave device. 2. Slow speed of the slave device. The slave devices use clock stretching to ensure the rate of data transfer is controlled. Let us now learn how slave devices can use clock stretching to slow things down during the data transfer, or I2C communication. In general, the SCL line, and therefore the I2C clock rate, is controlled by the master. However, there may be times where the slave device is unable to comply with the clock rate. The slave device may need extra time to process a command or send data. In such cases, the slave device may try to slow down the communication or data transfer through clock stretching. After a slave device receives a byte of data in transmission, it may hold down SCL longer, so that the master is required to adjust the clock. This is similar to clock synchronization. The master monitors SCL and is forced to extend the SCL pulse if it determines that SCL is still low after the master has released it. If clock stretching is supported by the master, any SCL pulse can be clock stretched by the slave device. However, the general implementation of clock stretching is done with the SCL pulse around the acknowledge bit. According to the I2C specification, there is no time limit to the slave holding down SCL for clock stretching. Here's an example of the slave device clock stretching SCL. In this example, the master issues a start and sends the slave device address. When the slave device recognizes the master is sending the proper slave address, the slave device then begins to acknowledge the address. If the slave device needs to slow down communications, it can pull down on SCL. This is the only instance the slave device can control the SCL. If the slave responds to clock stretching, it monitors SCL and sees that SCL remains low even though the master has released SCL. Because of this, the master cannot continue with the SCL pulse until the SCL is released by the target. The master continues to monitor SCL. Once SCL is released high, the master can then continue past the target device's acknowledge and continue with the next byte transmission. The resulting wired-end connection of SCL shows the SCL stretched. Data transmission is delayed by the slave device without disrupting I2C communication.